Good day. So before I start with this, I just wanted to, actually I'll tell you later, I'll show you the schedule after, but we finalized the schedule for the lightning talks, which are directly after this. There's a bunch of interesting stuff. I suggest you stick around. If you go to the Golang Twitter page, you'll see that schedule there. But right now I'm going to give my talk on the state of Go, just basically a state of the union where the project is at this point in time. So a little bit about what happened last year. In December we released Go 1.4. There were some important things about it, like we introduced the beginnings of Android support. The canonical import paths thing was actually pretty important in a sort of subtle way to do with the community and making sure everybody's using packages with the right import paths. And the Go generate command is also pretty interesting, and I think we're only sort of at the beginnings of seeing what people are using that for. But really what was going on in 1.4 was a lot of preparation work for future releases of Go. There was a lot of prep work for the new garbage collector, a lot of prep work for the conversion of the toolchain from C to Go, and so the source code was reorganized and a bunch of other stuff like that. You can check the release notes for more details. Around the same time as 1.4, but largely disconnected from the 1.4 release process, we transitioned from Mercurial to Git. And so that means the core Go repository and all of the sub-repositories, like the tools repository and so on, are now in Git instead of Mercurial. We converted all the change history across, all the data was preserved. And that also coincided with moving to new development infrastructure. So we're still serving our main repository with Google technology. So instead of Google Code, we're using googlesource.com, which is the same primary repo for Chrome and Android. And we're using Gerrit instead of Rietveld for code review, which is also coupled with that source code service. And we're using GitHub instead of Google Code for issue tracking and the wiki. And this is a big deal for Go contributors and some Go users, but for most Go users it's not really a big deal. It doesn't really affect how you use Go or what Go is about. But those are the URLs. I just wanted to touch on why we moved. Basically the reason why we chose Git is because we needed to move to Gerrit, and Gerrit uses Git. But why do we need to move to Gerrit? Because Rietveld, the code review system we were using, was basically unmaintained. It used to be used by the Chrome project, and so the fact that they were using it meant that there were people working on keeping it running. But then we were basically left holding the bag, and we were the last people using it, and we were like, well, this sucks. And so we decided to switch to Gerrit, which has a team maintaining it. It has a team actually maintaining the infrastructure as well. And so we joined large projects like Android and Chrome, so we're pretty confident that system is going to keep being worked on and improved for the better. And why did we move our issues and stuff away from Google Code to GitHub? Basically because now we can use GitHub. It puts us closer to our community, which by and large uses GitHub for its open source development work. And it means that other GitHub repos can mention like Go commit by hash or a Go issue in their issues and Go commits. And so it means we can kind of have a nice, more tightly sort of coupled relationship with other projects that use the Go core. So that's nice. There were some pros and cons to the transition. The pros are pretty significant, otherwise we wouldn't have done it. But like more people understand Git than Mercurial. And importantly, contributors can now use their own Git workflows. Previously with Mercurial, we kind of had this rigid kind of linearized process that you had to follow as a contributor. But now, because all of the sort of submission and merging is handled on the Gerrit server side, you can do whatever you want as a contributor in your own Git repositories. So previously we forbid our committers from using Mercurial extensions that let you sort of stack commits to do stuff like that, because we were afraid that you would accidentally push some big work in progress thing to the master repo. Gerrit is like a gatekeeper, and so we don't have to worry about that anymore. So now people can go crazy with Git, as they like to do. And that touches on the good integration between Git and Gerrit. Previously, Rietveld had nothing to do with Mercurial. It was just kind of, there was a vast disconnect. Git and Gerrit are thoroughly integrated. And also, now we have automated CLA checking. So the contributor license agreement is a way of saying as a contributor to Go that you have the authority to give the project the code that you're giving them. And so it means that anybody who uses Go is protected from any kind of spurious licensing claims down the track. Previously, we had to check a spreadsheet inside of Google to see whether someone had filled in a form. And we even had a tool to sort of automate that somewhat. But now we know if we receive a code review through Gerrit, that person has actually signed the CLA. And so us as developers don't even need to think about that anymore, which is great. There are a number of cons, though. Git has a steep learning curve. A lot of people who are used to our simple Mercurial-based workflow are now very confused, and I feel bad about that. That's just the nature of the beast. GitHub has no way to disable pull requests, which I'll talk about why that's a bad thing in a minute. GitHub also has no way to star or +1 issues, which I suggest everyone here just tweet at GitHub and ask them to implement this feature. Doesn't seem like it would be very difficult to do, but it kind of sucks getting an email notification every time someone says, oh, +1, this would be great to fix. It's like, yeah, I know. That's why it's on the issue tracker, and it's still open, and we're working on it. So thanks for the input. So actually, if you do write a +1, or if you have written a comment like that, we actually have a policy where we'll delete them, just because it sort of pollutes the discussion of the issues. So don't be offended if that happens. It's GitHub's fault, it's not your fault. Another unfortunate thing about GitHub is the standard of issue reports has gone down. And it's largely because on the old Google Code issue tracker, we provided this issue template. So when you go to file an issue, you would get a nice form where it said, here are the pieces of information we want, here's the format that we want it in. Now it's like you go to file an issue on the Go project and you get this blank box and you can just write anything. And so people do just write anything. Like, I don't understand why I need to import the thumbed package to print something. And it's like, this is not the appropriate forum for this question, so on. So that's a problem. It's a culture difference. And finally, it was a ton of work to transition, so that kind of sucked. But I think we're in a better place now, which is great. This is my final slide whining about GitHub. Why don't I like pull requests? A lot of people are really surprised that we don't accept pull requests, and so I think it's important to say why. It's not because we don't want to participate in like the GitHub way or like the open source community. It's not because we're not accepting patches or anything. We have our own system of receiving patches through Gerrit, but there are very specific reasons why we don't like pull requests. One of them is that the diff view is terrible. I don't know if anyone's tried to open like a 5,000 line diff across multiple files on GitHub. Even on a high-powered machine, it's really slow. I don't know why that should be, but it is. And like when you're reviewing code, you write comments, and like I might be reviewing Brad's code, and I'm like commenting, "Why are you doing this? Like this seems weird." Blah blah blah. And then I get 2/3 of the way through the review, and it's like, "Oh, I understand why he's doing this now." And then I go back and delete the comments. And that's what I would do in our old system, and that's what I'd do in Gerrit. But in GitHub, by the time I get down there, all of my comments have already been sent to him by email. And so there's no way for me to like back up and change my mind. And whereas in the other tools we're used to, you have this kind of atomic process where you draft all your comments and send them in one big batch. And it's really critical as a workflow thing. Yeah, you can't sort of look at differences between editions of the patch set as they evolve their change. You can't sort of see how it's changed. Yeah, you have to fork the repository publicly, which I think is just weird. When you accept a pull request, it creates a merge commit. We prefer to cherry pick the changes to the top of the branch instead. So we have a much cleaner history, don't have all these commits followed by merge commits. And in general, I think the whole way pull requests are created, it doesn't actually encourage people to review your code thoroughly. Whereas we have a culture of very, very thoroughly reviewing all changes. So it kind of didn't really work well for us.
I forgot another reason that side-by-side diff that Gerrit support and GitHub not.
I think GitHub actually just introduced side-by-side diff.
Oh, really?
Yeah, so.
Ah.
Yeah.
You've got this button for split screen, then it's.
Yeah. All right, so that's my whine about GitHub. I think they know that they can improve it, and they are working on improving it. Like, I think there's a lot of scope for improving developer workflow, and that's their business. So I trust they will get there in time. I think they're obviously we chose them, so we think they're good. It's not. I'm not saying GitHub is bad.
Just a small side note: OpenStack got a bot that auto closes all pull requests.
Yeah, we have the same. So Go 1.5, the future. I saw a talk yesterday which had this disclaimer, and I figured since we're basically it means that anything I say is purely speculative. I've replaced the various names with these things. Maybe you can figure out who that was, I don't know. So the release cycle has changed a little bit. We've pushed it out. Instead of releasing in June, we're now releasing in August. That's because everyone seems to be on a holiday in June. And also that put our other release in December. And so it meant that basically the whole period of when the tree opens again fell during the June holidays and also during the December, January holidays. And so the time when we needed people to be doing the most work was also the time when everybody was away. And so we've shifted it by a couple of months, and so now the freeze period is during the holidays. And so it means that, while we're not supposed to be doing work, we can be on holidays, which is perfect. So one of the major things about the Go core in 1.5, is the toolchain being converted from C to Go. So this started early last year. It's been going on in the background largely, mostly driven by Russ. And he told me a couple of days ago that it'll be done by the end of March, or maybe in the start of March. He said March. Basically, there is new linker and assemblers written in Go from scratch. And the assembler is actually, or maybe it's the code generation backend is actually pretty cool. It actually reads processor instruction spec sheets from PDFs and uses that to generate the tables from assembly instructions through to the actual bytecode output. So if you've seen Russ's PDF reader library, that's why that exists. And it's pretty hilariously awesome, actually. But the main meat of the Go compiler itself is being machine translated from C to Go. And that doesn't mean that we're going to have a C to Go translator that anyone can use. It just means that Russ is carefully massaging the compiler into a C program that looks like a Go program. And then we can instantaneously convert that to a Go program. And then we'll massage it from a Go program that looks like garbage into a real Go program made of several sub-packages and so on. So that's kind of happening, and that's what should be done very soon. But the upshot is that in 1.5, there will be no C code anywhere in the toolchain or even in the runtime. All the runtime code had to be converted by hand, and that was done by a lot of people on the team, and did a really great job of that. But what that means is that to compile Go 1.5 and later, you'll need to have a Go toolchain to do that. You don't need a C compiler anymore, but you will need a Go compiler to build them. And so the way to do that is just to put a directory in your home directory called Go 1.4 and put Go 1.4 in there. Or you can set the Go root bootstrap environment variable. One downside of this is that for new operating systems and architectures, you need to cross-compile instead of working natively, but that kind of works more easily in some ways anyway. But if you use the binary distro of Go, put your hand up if you download Go from golang.org/dl and install it that way. Not one person. Oh wow, a few. I spent hours and hours on this a few times a year. I could just not do that, apparently. Anyway. If you do that, then you don't need to do anything. Also in 1.5, we'll see a new concurrent garbage collector whose work's been going on for a while. Basically, the upshot of that is we'll have Go programs that are guaranteed to only pause for, say, up to 10 milliseconds on modern hardware. And it means that your Go program will be running 80% of the time in a sort of guaranteed fashion. So we're setting an upper bound on the pauses, so that'll be really nice for more interactive applications. If you saw Brad's talk on HTTP2, which is really great, you know that that's coming. It's probably not in 1.5 because the spec isn't standardized yet, but it will be in the standard library at some point. And it means that if you ever go HTTP server, when the HTTP2 spec is stabilized, it will become an HTTP2 server for free. You won't have to do anything. You can just write your servers as normal, and they'll speak HTTP2. So that's great. And I just want to show this demo once again, even if you saw it already, because I think it's so cool. In HTTP1, over a low latency connection, it can take a really long time to make all these requests, kind of in parallel, but mostly in serial. But HTTP2 lets you pipeline that, and bang. And so I think it's going to be fantastic, particularly on mobile platforms when this is fully rolled out. Speaking of mobile, a bunch of people have been working on porting Go to Android and iOS. So in 1.4, it was possible to build Android apps if you could work out how to do that with the Android build system, which, has anyone done Android work here? It's a bit tricky. But in Go 1.5, David, who's doing this, just snorted when I said it's a bit tricky. It's a bit of an understatement. So in 1.5, we hope to have some tooling to make the build story much more straightforward and much more sort of Go-like. You know, you write your code and then hit build and it works. Is that a rough approximation?
Yeah, let's say that.
Let's say that's going to happen. Yeah, better support for accessing more of the NDK, more of the Android APIs, better conventions and bindings for calling Go from Java. And also iOS is really exciting. So there's actually been an iOS port that's kind of been going along in the background for several years now, but we're actually looking at merging that into the core for Go 1.5. So that's really cool. And also related to that, some new architectures. So PowerPC 64. Who has a PowerPC 64 system? They're actually really amazing if you have one, and that's why none of us have them, because they're huge and awesome. Very industrial kind of settings that they're useful for. But also ARM64 is in the works. One of our contributors, ARM, has been working hard on that along with other people. So PowerPC64 is basically done. There is a builder running, it passes the test, so that will probably be in 1.5. ARM64, they have a stretch goal to have a branch in the main repo by 1.5. So it won't be available, but it'll be in development. And ARM64, of course, is important for iOS development because of 64-bit processors in the newer Apple phones. And you can actually see a work in progress of ARM64 in that GitHub repo. There's a new execution tracer that will be part of the Go toolchain. So you'll be able to enable execution tracing in your Go binary. And basically, that means your Go program will just dump tons of information to disk about what the program is doing and when. And then you can use Google's Trace Viewer, which is a tool. I'm not sure which team built it first, but both Android and Chrome use this to generate diagrams and explore these kind of logs of information. So this is a sort of shrunken down screenshot, but basically you can see which processes are running which code and when. And this is like a GC pause, and you can see like what's happening there. And then you can also see like the number of Go routines and all that stuff. And when you click on these things, you can actually see like which function it is and what it's executing and other information about the stack. This is showing this GC thing, but there's a lot of information in there. So the CLs, the changes to put this into the core were all sent out over the last week or so. And yeah, that's all rolling in. So there's a design doc you can see at that URL if you're interested. I'm pretty excited about that. Alan Donovan and some others have been working on tools for getting information about and also manipulating Go programs. And some of that is already in the tools repository. There are tools like CallGraph to sort of dump the CallGraph Go program, which is useful for piping into other systems that can visualize that kind of stuff. And there are two tools, Go Move Package and Go Rename, that can be used to, in a type safe or file system safe way, change the names of things, move things around, just to make it easier to like correctly refactor programs. And those programs are ready for use now. I also saw a demo of a program called SockDraw, which is still in a change that's being reviewed somewhere. But basically, that allows you to take a package and say, I want to move these parts of the package into another package, and it will grab all the internals that it needs and only take the sort of internal dependencies of those public bits. And so that's kind of that should be quite useful. If you find yourself building a util package that just grows and grows and grows, and you shouldn't do that, but if you do, that will be a useful tool for you. Brad has been mostly leading the charge on this. I've been helping by reviewing his code. But basically, we have our own homemade continuous build infrastructure, largely because when you're developing a programming language, you kind of are at the very bottom of the stack, and a lot of the existing infrastructures kind of didn't work out well for us at the time. But so it's now, the new infrastructure is now running a lot of our builders on Google Compute Engine. And we hope to be running OS 10, not on Compute Engine, on a different farm of machines, and also Windows pretty soon. But the really nice thing about it is we can spin up huge amounts of machines to churn through our builds when they're happening. And so we get our results a lot faster. And also we'll be able to test, like speculatively test changes and see if they work before we commit them, which will be really nice. It's not really any big news, but it's good news for us.
Is this integrated in Gerrand verification chain?
It will be integrated with Gerrand, but it's not right now. But another cool thing that it's given us is this tool called GoMote, which I can demo really quickly. Basically, a really common thing for us is you'll break something you'll break something on OpenBSD, and then you'll be like, how do I fix that? I need an OpenBSD machine. Who runs the OpenBSD builders? You send an email, they give you, well, what's your SSH key? You can log in or create you an account, something like that. Big waste of time. Instead, now we can say GoMote create and spin up a VM running exactly that builder's environment. And I probably should have done this before I started the talk, because it takes about 30 seconds. But this is hitting Google's Compute Engine APIs and starting a new VM, which is running an image that we pre-built, and it's stored in Google Cloud Storage somewhere. And then once the instance is created, it waits for it to boot up. The instance actually pulls down a version of this buildlet program, which is a program that just listens via HTTP and awaits instructions from me, the user. And so now it's created, I can actually say, like, I can issue commands to it. So, for instance, I can say, just list the file system root, and it will run it on that remote server, and then show me the results. More interesting is I can say, I can put a tar file from my system, or even just put a file. But a nice thing is I can say, I want to put Go revision, whatever that is. Hang on. I can put this Go revision. Can you put that in the top? Sorry?
Can you put that at the top? The command that they can see the command from the backside.
Oh. Yeah, okay. How can I do that? Yeah, there you go. I'm in screen, so I wasn't sure it would work. But then I can put a particular revision, and it will actually just pull it out of source control. And the nice thing is that revision can be any revision that you've uploaded through Gerrand. So it could be an in-progress change that I have or something like that. And so once that's been shoved onto the machine, it will return, and I'll just start typing. Oh, now that I've put it, I can run, instead of binls, I can run source/make.bash and actually start building, Go on that machine. So now I'm getting the standard output and error of that command running remotely. And so this is going to be really nice for us as a development thing. It may get spun out into something more generally useful. We'll see. I'll just leave that running. Cool.
Contributor cannot use it directly, right?
Right now, a contributor can't use it directly unless you're one of the committers and you have a key that we'll give out. And that's largely because it then gives you being able to use that program gives you access to our Google Cloud project, and so you could like create instances and start a botnet or something. I don't know. Use your imagination. Oh yeah, so the idea will be that you can use your own, you'll be able to specify your own project and use it yourself, and you just pay for like, I think Google, the compute engine charges you by the minute after the first 10 minutes or something. So it's actually quite conceivable that it'd be quite cheap to work that way. Cool. So that's the Go core. As far as the Go community is concerned, there's a bunch of Go conferences around the world, and more to be announced. There's FOSDEM, we're here right now, hooray! There's GopherCon India in Bengaluru, and that's what was called Bangalore. If you didn't know, they renamed their city recently. That must have been really difficult. There's GoCon in Tokyo. It's been happening twice a year for the last 2 or 3 years, so I presume it's going to continue happening. There's GopherCon in Denver. Did anyone here go to GopherCon? A few people did. Yeah. So it's going to be like twice the size this time, which is a little bit scary for me. But that should be great. We had a great time last year, so I suggest you go if you're at all interested. And .go will be happening in Paris later in the year. But there's more stuff that I'm aware of that I can't say. But that'll be cool. And also there was the Gopher Gala. Did anyone participate in the Gopher Gala? Anyone here? A couple of people? One person? So the Gopher Gala was a global Go hackathon that happened last weekend. And there were teams that would produce apps that were judged by their usefulness, creativity, completeness, and how well they showcased Go's strengths. It didn't just happen online. There were also physical locations around the world, about 30 of them, where people got together and hung out and hacked on Go stuff. There were really cool prizes, actually. You could get a Chromebook Pixel, like Raspberry Pi, all kinds of techie stuff, GitHub accounts, and a trip to Mexico, which I thought was totally amazing. And it's like to Colima, which I'm not sure what that's like as a place, but basically it's a company has invited you to fly you out so you can hang out with them and like hack in their office or just go to the beach or whatever. I hope it's on the coast, otherwise that makes no sense. But the winner is still yet to be decided. The judging is happening at the moment. And you can actually check out the entries at gophergala.challengepost.com/submissions. And I just wanted to highlight a couple of entries that caught my attention that I thought were pretty cool. There was Gophy, which is neat because it uses Tor to set up monitoring of your websites. So you'll have these Tor exit nodes hitting your websites, which is kind of cool. Might put you on a watch list. I don't really know. Use your best judgment. But it seems like a cool project. I like this one, the Golang size of tips. So, where is it? No? There was a link. Oh, there it is. It's got a cool domain, golang-sizeof.tips. But basically, you put a Go struct in and it shows you the packing of the struct. So you can see if you want to optimize the packing of your Go structs, it will tell you whether it's optimal or not. And so, you ask the Gopher, so it says it will explain. And so that's well packed. If you put something, small in there, it becomes unbalanced and so on. So that's kind of cool. I like this one too, a Go report card. It's a website that you give it your project's import path, and it will run like gofumpt, golent. I don't know what gocyclo is, and govet over your repo. So if I put something of mine in there and run it, it will tell me that it's 85% that. Oh, this tests the cyclomatic complexity of your source code. I'll have to look at that later. But it's telling me, that I should definitely be documenting all of this stuff, and it's definitely true. So put your stuff in there and see how it goes. Actually, I'm curious about this. Great, you got an A. And this one's kind of cute. It's not Go related, but it's written in Go. It's a command line tool where you can record a voice message and it will encrypt it and mail it to someone. And so, you know, if you have like some secret love and you want to whisper sweet nothings from the command line, you can do that. So that's awesome. But yeah, there's like 128 submissions, which is a really great number. Good enough reason to look at them all, each and every one. So definitely check it out. It's worth looking. Yeah, I had where did my slide go? Ah, there it is. Also, I just wanted to mention, who here has gone to a Go user group meetup? Okay, that's like not enough, nearly. Who here knows that there's a Go meetup in their city, but has never been to it? Aha. So you should go to gomeetups.appspot.com, which Francesca wrote. And it actually lists, it's a machine-generated list, so it's probably not complete, but it lists Go meetups and their sizes and their cities and so on. So look for your place, get involved in your local Go community. If there isn't one, then the onus is on you. I command you to start one in your town. And we're going to kick up a program to start distributing cool things like these plush gophers and t-shirts and stickers and stuff to all these places. So that's a reason enough to get involved. Yeah, yeah, please do. I mean, it's really fun. Like, I run the Go meetup with Dave Cheney in Sydney, and you know, we always have interesting talks and fun things going on. And I don't know, it's just Go people tend to be a nice crowd. I like that. Cool.
Can you please hold on? I would like to.
Oh yeah.
Thank you.
Yeah. So that's the URL. But that's the end of my talk. So thank you very much. And I'm happy to answer any questions, of course. Yeah.
Are there any plans for some kind of version support in the imports? Like
Right. The question was, are there any plans for there to be versioning in imports or some kind of version control, version management system? The answer is no, we don't have any such plans. Peter's talk kind of made me feel bad. I don't really know like what I can do as an individual to fix this problem. I think that, you know, he actually mentioned like, oh, we should try and export some of the way that Google manages this stuff. But the way we manage it is we have one giant source repository, and we put everything in that, like everything Google does and all of our dependencies. And so like when you want to update one of your dependencies, you import the latest version of that code from its external repository and check it into our big repo. And it means that at the time that you do that, you have to update all of the code that depends on that. We have infrastructure to run all the tests and so on. But like, pretty much anybody I've ever mentioned this approach to just thinks it's crazy, like outside of Google. It works really well for us because we have the infrastructure to support it, and because we're just one big company where, you know, we can have policies that state, you know, you need to not break the build. But you can't just tell someone on the internet to not push to their GitHub repo. So it's a little bit, the approach that we take is not one that can actually work outside in a global sense. Although probably what Peter was saying is maybe we should try and make it possible for organizations like what he was describing, the modern enterprise, to take a similar kind of approach. But yeah, as far as like on an open source kind of internet level, I really like the approach that Gustavo Niemeyer took with gopackage.in, which is like versioned import paths. That's one approach. The other approach is just vendoring everything when you care. But there are caveats with both of those approaches. You know, you still have the diamond dependency problem, which is theoretically intractable, but we don't actually even have the tools to tell you when that's the case anymore. In Go, rather. So I think there's definitely work to be done, but I'm not sure what the solution is. So I apologize for that wholly unsatisfying response to your question. Yeah.
The binary size for a compiled, it's hello world and the big
Yeah.
program is still large.
Yeah. So
What's the difference?
yeah. So you're asking what's the deal with large binaries?
Yeah.
Is that?
And if it could be shrink.
It's actually gotten smaller over the last couple of releases. Oh, so the question was, why are Go binaries so big, and are they going to get smaller? And yeah, they have been getting smaller, but the fact is that all Go binaries are statically linked. If you statically link like C's hello world, it's about half the size of Go's hello world. But C's hello world doesn't do Unicode. It if you type funct.println hello, it actually does a ton of reflection and other stuff to make that possible. Actually, at GopherCon last year, Rob gave a talk where he broke down what happens when you run hello world. So there's actually a lot baked into that. So I don't really feel like it's unreasonably large. We do have a tracking bug to sort of reduce the size. But the fact is that when you add more to the Go program, it doesn't necessarily grow like proportionate to the size of the source code. There's just kind of like a baseline large size. Fortunately, disk space is cheap. So, you know.
The internet is fast.
Yeah, the internet is fast, that's true. More questions?
How has progress been on the proposal for being able to call Go code from C, as well as generating shared libraries, and two other options that were in there?
Yeah, so the question was, how has there been any progress towards, I believe it was Ian Taylor's Go execution modes document, where he described ways of calling into Go code from other host languages, and also calling into other languages from Go. And probably David will mention a bit about this in his lightning talk on Android, because it's heavily related to running Go on Android and iOS, being able to do that. I don't really know. Not a huge amount has tangibly happened. The toolchain is all kind of in flux right now, so work like that is kind of hard to get done in the changing tree right now. Anyone else? Wow, okay, cool. Thank you, everyone.